We have a block of mass 2 kgs placed on a long frictionless horizontal table. So 2 kgs, and it's placed on a long frictionless horizontal surface. So we don't need to take care of anything about the friction coefficient or the friction force. And it is pulled horizontally by a constant force F. So a constant force F applies here. This is a very rough representation of what is happening. It is found to move 10 meters in the first 2 seconds. So this moves 10 meters in 2 seconds. Find the magnitude of F. So we do know that F equals ma, that's Newton's second law, and this is sum of all forces, and the only force acting here is this force F. So F is equal to, the mass is 2 kgs, 2 kilograms. Let's just skip units since everything is in SI, and that times the acceleration that it gives, and since it's a constant force you can just write a, and that means that the acceleration is equal to the magnitude of F over 2. Now we now have the acceleration in terms of the force. We know that it runs certain distance in certain time. So there is this equation from kinematics which says that the displacement of an object is equal to its initial velocity times the time it has run plus half at squared for constant acceleration. And since F is constant, this a is also constant, and you can apply this equation here. Now it starts from rest, so u is equal to 0, this term goes out, and s is equal to 10, that's given here. So 10 is equal to half a is f over 2 times t squared, and t here is 2 seconds, so you can just write 2 squared. Just solve it and you will arrive at, you have 10 on this side, and 2 times 2 cancels 2 squared, so 10 equals F. And since we were doing everything in SI units, you can say that the force F is 10 newtons.